G'day guys, going to go through another software design development HSC question 32D from the 2019 paper, and the question has given to us a logic circuit. It asks us to consider this logic circuit, and it says draw a circuit that is logically equivalent to the circuit above, which uses the fewest number of gates. Support your answer with a relevant truth table. Alright, so let's start setting up our truth table. So we've got our inputs on the left hand side, A and B. We've got a couple of intermediate values, W, V, X and Y. So W, V, X and Y, and our output Z. Mark that on the table there. Draw a couple of columns up. And then for our A and B, I like to count from 0 in binary until we get all ones. So we've got 0, 1, 2, 3, all ones. And now we'll just work our way through the truth table and filling in some values. So let's start with W, our next column along. And W is inverted from B. So we're just going to take B and invert it. So 1, 0, 1, 0. So just invert B. We'll go to our next column, V. If we look at V, V is inverted A. So we'll invert A. So 1, 1, 0, 0. We'll keep working our way along up to X. So we're looking at X here. So X is an OR gate, and the inputs to the OR gate are B and V. So we're looking for when B or V are on. So B or V there, and then we'll do similar for Y. So Y is also into an OR gate. The inputs to the OR gate are W or A. So we'll look for when W or A is on. Nothing's on there. A is on there. A is on there. And then lastly, Z, our output, goes through an AND gate. The input to the AND gates are Y and X. So we'll look for Y and X on together. Only one of them, and they're both on here. So there's our truth table for that circuit there. Now the next part here, we need to draw a circuit that's logically equivalent. So if we consider that truth table for a sec, and if we recall, if we wanted to draw the truth table for an XOR gate, A XOR B, I might just do this on the side here. So there's my XOR gate and an output. If I quickly draw the truth table for this, A, B, XOR, so an XOR is one or the other, but not both. And if we look at that, we might see a pattern here. So one or the other, but not both. Now if we compare these truth tables, so if we look at the first line, we've got a 1, we've got a 0. Second line, we've got a 0, we've got a 1, 0, we've got a 1, a 1, we've got a 0. So what I want you to see here is that this column in our truth table here is the complete opposite of an XOR gate here, just by inspection. So our simplified circuit, knowing that, is going to be the inversion of an XOR gate. So we know that it's the complete opposite of an XOR gate, so I'm going to draw an XOR gate, an inverter, And there's a valid solution there, which is certainly simplified, but I could be a little bit more condensed as well. And I can put the inverter as a little circle on top of my XOR gate. And I'll just label these here. So I guess we could call this one a not XOR gate.